So when an interrupt service routine is executed, the flag registers will be altered, and also some general purpose registers also will be altered. So before going to the interrupt service routine, we need to store all these informations. That is the current value of the program counter, the flag register, content of the flag register, and also general purpose registers. But the storing all these information will take time consuming. That will increases the interrupt latency. So interrupt latency means the time when an interrupt occurs and the time between the interrupt occurs and we start the interrupt service routine. So to reduce the interrupt latency, some processor will store only the minimal amount of information. The minimal amount of information includes the program counter value, the current program counter value, and also the processor status register. If we need to store some additional information, we need to inform it by, we should specify it explicitly by the interrupt service routine as an instruction in the interrupt service routine at the beginning. So this is the interrupt hardware. So the interrupt, we have a dedicated line, that is interrupt request line. All the IO devices are connected to the interrupt request line. And this interrupt request line is connected to VDD by a pull-up resistor. So initially the INTR bar will be high, and here we have a NOT gate, and the interrupt request that is given to the processor will be a low signal. So this is the hardware connection of an interrupt, that is all the IO devices. These are the IO devices that is connected to the interrupt request line. So this interrupt request line, and the interrupt request line is connected to VDD by using a pull-up resistor. So when a device want to request an interrupt, it will request the interrupt by closing the switch. So this, when the switch is closed, the interrupt request line is connected to ground. So if the devices, if no devices are requesting an interrupt, the interrupt request line will be high, and INTR, this is INTR bar, and it is gone through a NOT gate, and the value of INTR will be 0. So when a device requests an interrupt, if interrupt the second device, that is INTR2, this requests an interrupt by closing the switch, the value in this will be grounded. So the value INTR bar will be 0 and INTR will be 1. So the processor will get an interrupt request. So we notified that an interrupt is requested by one of the devices. So since closing of one or more switches will cause the line voltage drop to 0, the value of INTR is logical addition of all the requests. If many devices, one or more devices, when it requests the interrupt, the value will be gone to low, and here a request is not. Enabling and disabling of interrupt. The interrupt request the execution of a program. When an interrupt request comes, it interrupts the execution of a program and may alter the intended sequence of events. So sometimes such alteration may be undesirable and must not be allowed. For example, the processor may not want to interrupted by the same device while executing the interrupt service routine. So the processor generally provide the ability to enable and disable such interruption as desired. So one simple way is to provide the mechanism, provide a machine instruction such as interrupt enable and interrupt disable for this purpose. So to avoid interruption by the same device during the execution of an interrupt service routine, the first instruction of an ISR can be interrupt disable, and the last instruction of an interrupt service routine can be an interrupt enable. This is one of the mechanisms. Handling multiple devices. So multiple IO devices will be connected to the processor. So how to handle these multiple devices? So multiple IO devices may be connected to the processor and the memory via bus. Some or all these devices may be capable of generating interrupt requests. So the processor need to handle these requests from multiple devices. So each device operating independently, and hence not definite order can be imposed on how the device generate the interrupt request. So the techniques are polling, vectored interrupts, interrupt nesting, and daisy chain. So first one is the polling scheme. The interrupt request bit in the status register is set when a device is requesting an interrupt. So the interrupt service routine calls the IO device connected to the bus. So the first device encountered with the interrupt request bit is serviced and the subroutine is invoked. So this is easy to implement, but too much time spent on checking the interrupt request bit IIQ bit of all devices, though some devices may not be requesting services. So an alternative approach is to use the vectored interrupt. So vectored interrupt means the device requesting an interrupt identifies itself directly to the processor. This device, if the fourth device is requesting an interrupt, the fourth device will identify itself to the processor by sending some codes. So the device sends a specific code to the processor over the bus. So this code contains the identification of the device, the starting address for the interrupt service routine, and the address of the branch to the ISR. So the PC finds the ISR address from the code. So ഈ കോഡ് ആയിരിക്കും കോഡും കൂടി സെൻഡ് ചെയ്യും. ആ കോഡ് സെൻഡ് ചെയ്യുന്നതെന്ന് വെച്ചിട്ട് ആ ഡിവൈസിനെ ഐഡന്റിഫൈ ചെയ്യും. അതുപോലെ റിക്വസ്റ്റ് ചെയ്ത ഇന്ററപ്റ്റ് സർവീസ് റുട്ടീൻ എവിടെയാണെന്നുള്ളതും ഐഡന്റിഫൈ ചെയ്യും. So to add flexibility of multiple devices, the corresponding ISR is executed by the processor using a branch address to the appropriate routine. Device specified interrupt vector. So this is called the interrupt vector. So an interrupt vector is the memory address of an interrupt handler or an index to an array called the interrupt vector table. A table of interrupt vectors, that is pointers to routine that handles the interrupt. നമ്മളൊരു ഇന്ററപ്റ്റ് വരുമ്പോൾ we execute the interrupt service routine. അതിലോട്ട് പോയിന്റ് ചെയ്യുന്നതാണ് ഈ interrupt vector table എന്ന് പറയുന്നത്, interrupt vector. Nesting of interrupts. So the preemption of nesting of interrupts means when we are executing a low priority interrupt, when a high priority interrupt comes, the low priority interrupt will be stopped and the high priority interrupt will be served. So നമ്മളൊരു പ്രോഗ്രാം റൺ ചെയ്തുകൊണ്ടിരിക്കുമ്പോൾ ഒരു ഇന്ററപ്റ്റ് വരുമ്പോൾ നമ്മൾ ആ റൺ ചെയ്ത പ്രോഗ്രാമിനെ സ്റ്റോപ്പ് ചെയ്തിട്ട് ഇന്ററപ്റ്റ് എക്സിക്യൂട്ട് ചെയ്യാൻ പോകും. So first നമുക്ക് കിട്ടിയത് ഒരു low priority interrupt ആണ്. So first when we are executing that low priority interrupt, a high priority interrupt comes. So ആ interrupt service routine അവിടെ വെച്ച് നമ്മൾ സ്റ്റോപ്പ് ചെയ്തിട്ട് high priority interruptന്റെ interrupt service routine execute ചെയ്യുന്നു. That process is called interrupt nesting. That is preemption of a low priority interrupt by other high priority interrupt is known as interrupt nesting. So disabling interrupts during the execution of ISR may not favor devices which need immediate attention, need a priority of IQ, interrupt request devices, and accepting interrupt requests from a high priority devices. So the priority level of the processor can be changed dramatically. So here multiple devices, each device has a separate interrupt request, and here you can see that P number of devices are connected and all the devices is having separate interrupt request line and interrupt acknowledged line. So this is interrupt request line. When the device need to access the processor, it raises an interrupt and the interrupt will reach the processor. Different interrupt request lines are there and different interrupt acknowledged lines is also there. When the processor gets the interrupt, when the processor it acknowledged by sending a interrupt acknowledgement to the particular devices. So each interrupt request line is assigned with different priority. So it is given a priority arbitration circuit. The interrupt requests received over these lines are sent to the priority arbitration circuit in the processor. And if the interrupt request has high priority, then the priority of the processor, then the request is accepted. Currently execute in ISR column greater priority interrupt the processor will stop the ISR there and executes the requested interrupt. So IO devices are organized in a priority structure. An interrupt request from a priority device is accepted while the processor is executing the interrupt service routine of a low priority device. So the priority level is assigned to the processor that can be changed under program control. So the priority level of a processor is the priority of the processor that is currently program that is currently being executed. The processor or program executive ആണെങ്കിൽ processor priority ആ പ്രോഗ്രാമിന്റെ priority ഏതാണോ അതായിരിക്കും processor priority. അപ്പോൾ processor-നേക്കാളും കൂടുതൽ priority ഉള്ള ഒരു റിക്വസ്റ്റ് വരുവാണെന്നുണ്ടെങ്കിൽ processor currently execute ചെയ്യുന്ന program അവിടെ stop ചെയ്തിട്ട് high priority programs ആയിരിക്കും അവിടെ execute ചെയ്യുന്നത്. Another method is daisy chain pattern. Daisy chaining means here the interrupt request line is common. Here you can see that INTR line is common for all the devices, and the interrupt acknowledgement line is connected to the device in a daisy chain pattern. This is the daisy chain pattern. Interrupt request ellam or common line lote connect cheyidittu it is given to the processor, and interrupt acknowledge is given to the first device, and through the first propagate idana povunnathu. So through the first device it is connected to the next device. So here higher priority devices will be connected first. Device 1 in higher priority compared to device 2. So this high priority device will be connected first and low priority will be connected the least. Daisy chaining with priority group. Here a combination of interrupt nesting and daisy chaining scheme is used. Devices are organized into different groups and each group is assigned with different priority level. So INTR1 will be having higher priority than INTR2. Also different groups are connected, and all the devices within a single group share an interrupt request line and are connected in the form of a daisy chain pattern. Next is DMA controller.